So the problem says that there's two speakers that are equal, so they are seeing everything, and they are 2 meters apart. And 3 meters apart of one speaker, there is a person. So he's hearing things. Well, he's hearing with a frequency of 300 hertz. So the first question, we are going to find the phase difference between the waves when they reach the observer. So to find the phase difference, we have this equation that is the change of phase difference is equal to P times delta X divided by lambda. So we just have to substitute in here. So we're going to substitute. So we know that, well, this is our x2, so we need to find this x, but we have 2 meters and 3 meters, so we know that it's 2 squared plus 3 squared square root. So we can do that, and this is the square root of 4 and 9 thirds. So we can substitute in here, but so we substitute it's equal to 2 pi times delta x. So we know that delta x is x2 minus x1, so it's going to be the square root of 13 minus 3 divided by lambda. We don't have lambda, but we have this equation. So for here we can solve for lambda, and it's going to be velocity divided by frequency. We have the velocity because it's sound, it's moving at the velocity of the sound, so it's going to be 343 meters per second. So it's going to be 343 divided by 300 hertz, the frequency. So this is going to be the change of the phase. So we can do that in our calculators. So it's going to be 2 pi times square root of 15 minus 3 divided by 343 divided by 300. So it's going to be 3.3278, and because it's the phase, it's going to be radians, so this is going to be the answer A. And in the B, we need to find the frequency. So this wave is not a constructive wave, so it's a destructive wave. So we have to make it constructive. So we need to find the frequency when it reaches the minimum sound. So we need to find. And for that, we know that delta x equal lambda divided by 2, because it's lambda divided by 2, lambda divided by 4. I don't know, just lambda divided by 2. So we can know that 2 times delta x is going to be equal lambda. So we need to find a new frequency. And we can solve frequency for this equation. So it's going to, frequency is going to be velocity divided by lambda. So we have frequency, it's going to be the velocity of the sound, it will be the same, 343 divided by lambda. Lambda is 2 times delta x. Delta x is the square root of 13 minus 3. And this is going to be our new frequency, well, the minimum frequency. So if we do that, we can so the answer is 3.213. So this is going to be the frequency which